Hello and welcome to this video from Medical Bridge. In this video we are going to demonstrate private cloud private access in action in the cloud security connector for Zscaler. The use case of the connector, as we mentioned several times, is cloud migration when you need to connect to Zscaler from Amazon, Azure, or Google Cloud, or when you want to connect to Zscaler via in your branch office or data center. One of the objectives is simplifying network security, and here PriCPA plays an important role because PriCPA allows you to secure site-to-site, site-to-cloud, and cloud-to-cloud traffic with zero trust, creating a full mesh among all your sites without the need to create a single tunnel. It's extremely simple to configure and secure. This is why we say one of the use cases of the connector is simplifying network security. And the other application was SecureNet. We mentioned this in the previous video, but right now we are going to put focus on PriCPA and how to secure your private communication site-to-site, site-to-cloud, and cloud-to-cloud. The connector has different functionalities, different connectivities. The most important two are to connect to Zscaler, internet access, and to connect site-to-site, cloud-to-cloud, or site-to-cloud. This functionality is called private cloud private access. Is our invention. We invented private cloud private access as an easy way to do communications. Why private access is needed, or something is needed? Because cloud networking has failed. Too many pinpoint separate solutions to connect from site to site or branch. You have VPN gateways, direct connect, cloud one, cloud firewall, private links, virtual ones, MPLS, network connectivity sector, blah blah blah, you name it. There is multiple solutions that all are like a workaround, and you can use this when you want, or this when you need, and are complex. They are involved routing, they involve all things that make very difficult to connect to provide secure connectivity to cloud environments, especially for the DevOps people, but for everyone. And the cloud security connector is the ultimate solution, effectively replacing all other options. All of this, you can replace all of this. And let's see how we replace one of them, the most popular, because the most popular solution to go to the cloud is to use VPN gateways. How this works: from your firewall or in your data center, you create an IPsec tunnel to the VPN gateway. That is okay when you have one single connection to the cloud, but when you have multiple connections to the cloud, moreover, when you have multiple clouds, it's extremely complex to do. Because the communication, you need to create tunnels. If you want to do a full mesh communication, you need to create tunnels, multiple tunnels. And for example, if you have 10 sites to connect, the rule is 10 by 9, that is divided by 2 is 45 tunnels. Then you're not going to do 45 tunnels. It's completely impractical. The other problem with this solution is that it's very expensive, because the VPN gateways, you need to pay per tunnel, per VPN gateway, per bandwidth, per, and it's very easy. As soon as you add more sites, it's very easy to need a bigger VPN gateway, and that the base is very expensive, the bigger is more expensive. Then think that on the connector you have this functionality, and the truth is you are paying the connector because it's Zscaler, then it comes for free, this functionality at the end. And the other drawback of this solution is not zero trust. It enable full connectivity. Then if you want to create some kind of zero trust, you will need to create firewall rules here, security groups in AWS, different security groups configuration on Azure, and firewall rules in Google Cloud. That you can't create a uniform policy for all sites with this technology. because all are proprietary. And it's very complex to create and maintain. If you want to, you need to use BGP for communications. If you want to do peering or BGP peering here to try to make a fast conversions of routing is a nightmare. Then at the end, this problem is what we solve in a very easy way with PriCPA. Then remove the gateways. You don't need to do any tunnel. Promise. We will show you the configuration in the next slides, and use PriCPA for connectivity. The configuration to PriCPA is extremely simple. It's only 2 steps that you onboard the connector to the PriCPA cloud, and after you need to create the policies saying, for example, this device will talk with this instance, but not with this one. And this device will have visibility of this instance in the port protocol, but this instance will be invisible. This is the concept of zero trust. You can get access where you need only, not other devices in your cloud. And the main benefit here first is savings, because you are not paying any more VPN gateways. The price is predictable, because you pay per license, per CSE. This feature is not per user, it's not per tunnel. It provides any-to-any communication instantly. You can communicate from here to here to here to here, and you don't need to do any tunnel. The connector is smart enough to create, because we use something called crypto key routing, that is packet per packet encryption. As soon as this machine needs to connect to this one, this connector will initiate the communication. I will establish the encrypted communication to the other side. All traffic is encrypted. All protocols are supported. This is important. It's not a solution like other solutions like this that are saying, okay, you can use TCP, but you cannot do PIN, or maybe voice over IP or something like that. You can pass whatever you want here. It's very scalable. If you want to, you can add multiple sites, and also you can create multiple clouds if you want. It is zero trust, as I said. You can create policies per source, destination, protocol, and port. It is networking as a code. Yes, it's not command line. It's not a command. It's a simple JSON file, and you can distribute the JSON file to all connectors, and the connector will create all the rules for you. It's very automated deployment via Terraform or via CloudFormation or template, RAM templates. In general, I would recommend to use Terraform. Two-step configuration, as I mentioned, onboard the node to the cloud, and then deploy the zero trust rules. It provides visibility traffic end-to-end. This device will see the source IP of this machine. There is not NAT in the middle. It's not blocked. Then your developers will not complain at all for this solution. That's a classic problem for developers when you have NAT in the middle. Traffic visibility end-to-end, of course, you can see all the traffic end-to-end. It blocks lateral movement, we mentioned that, and its high performance is 1 gig per site, but you can grow more if you want. How this works? Well, the way that this works, it's quite simple, and anyone without a deep networking knowledge can create a full mesh encrypted network with zero trust. The only that you need to be aware is a public IP, is a private IP for the node, a private IP, and the subnets behind the node. 3 values, only 3 values. Anyone with basic knowledge on networking can do this. Then let's go for the detail. Each site needs a public IP, a static IP. The cloud, the PriCPA cloud, needs a subnet as well. Each node in the PriCPA cloud will be assigned with an IP from the cloud, in this case number 1, number 2, number 3, number 4. And finally, I need to know the subnets behind each node. With these 3 values, I have ready the full mesh network. And how the magic works. the connector is smart enough to communicate. Let's say we want to communicate this laptop with this instance. This laptop will initiate communications to, for example, IP 10.1.5.5. Okay. Then when this communication starts here, this connector say, okay, you want to go to 10.1.5.5. This subnet is behind this public IP, and this connector will send the packet to here. And this connector will say, okay, yes, as I said, there is an exchange of key, blah blah, all the encryption set up, and this connector say, yes, I accept this communication, and it will allow you to connect. Then, as simple as is, you are going to create a full mesh encrypted network. Only 3 values: static IP, one IP for the node of the private cloud, and the subnets behind. How is the configuration? I mentioned before there's 2 steps. First step is create the local configuration, and here you need to enable private access, and you need to put the node name, location, blah 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 blah, and some information. And here is where the keys are generated, the public keys. With this information here, you need to copy this information and paste on the peer JSON file. This is the file that will be distributed to all connectors on my cloud. And from the information of this file, the connector will create all channels, all encryption, all full mesh, and the rules. Then the first information is the local configuration, the second configuration is the networks behind the node, and finally the apps that are on this location. For example, this location, I have this IP 10.2.4.4 that I'll allow this destination to be accessed from these source IPs, that is management networks, using TCP and port 22 and 3389. Again, you don't need to be a CCIE in routing and switching. You only need to understand basic networking, IPs, subnets, netmasks, port and protocol, and you will be able to create a full mesh encrypted network with zero trust, thanks to the intelligence of the connector. For the demonstration, we are going to use a connector on AWS. We have different videos with this. In this series of videos, we have different videos with this connector. Remember, it's a connector that is already connected to Zscaler. It's also connected using the NAT gateway, outbound firewall, and doing bypasses here. And now the next line we are going to connect is to onboard the connector to our own PriCPA cloud. Our PriCPA cloud currently have I don't know, 20 nodes, something like that, in Australia, Japan, United States, and South America, Scotland, multiple places in the world. And we are going to onboard this connector that is in Ohio, in AWS Ohio. And the test will be from Azure. I will try to ping one instance and the other instance. This is the 2 instances I have behind. And let's see what happens. I will create rules allowing to ping one but not the other, and I will allow to SSH both, for example. Then let's go and let's see the steps. Then the first thing I need to do is to create local configuration. Let's do it. Then I'm going to my connector here. This is my connector on Ohio, and I need to pick up some values here. That is the public IP, the PriCPA of the node. I have already the values. First thing first, go to the connector and get your public IP for PriCPA. That is the same IP than the firewall and bypass. Copy. Okay. Now let's go to 18 local configuration. The first thing I have here is saying please apply this role. We already did, because this is the same role. We applied the role at the moment of the installation. Then I don't need to do it again. Then what I'm going to do is manual configuration, and you need to have these values ready. Do you want to continue? Yes. Then node name, I will show this CSC Zscaler PriCPA in Ohio. Okay. Location name AWS Ohio. Oops. Okay. Description. This node is for the demo. Public IP and UDP port. Then for public IP, I will use this public IP. This is the public IP of the connector. And the port is, I will use this one. This is a standard port. Private subnet of the local interface. Then on the local interface, this is the IP of the connector in the PriCPA cloud. And the netmask is 24. Okay. Do you want to enable persistent keep alive? Yeah, let's do it. You can say no or yes. It depends. If you have multiple nodes with constant traffic, you can put no, but when you have a little node, it's better to put yes. And I say, do you want to apply the values? Yes, of course. Okay, now I have the information of the peer file. I have the local information. And with this information, I need to fill, let's watch the second step, add the local configuration to the peer JSON file. Perfect. Then let me see if I copy. Then this is my peer JSON file, and I will update today as 07.10. Let's put another one version more, and let's add this node. Little comma here. This is the node. Now on networks behind, I need to add the networks behind, and what I'm going to do is to put the networks behind this node. That the networks behind this two. Let's put on the format. Require. Copy. Networks behind. Okay. And finally, private apps. On private apps, I will pick up this as an example, and let's put a private app. I will put now that I allow to this Ubuntu machine. Let's do a role here, and I will say to this machine only. Let's delete the other thing. I will allow all traffic to 32. Okay. And I will add another rule that I will say copy. Remember the comma. Allow SSH to the other one, the 67. Protocol TCP port 22. Okay. Then I have two simple rules, and this is my JSON file now. Local configuration, subnets behind, apps. Remember, the logic of configuration of the private apps is to destinations behind these subnets, who will access, in this case is everyone, and in which port and protocol. Okay, no, it's not a classic configuration user to application. This user can access. In this case, we do a little on reverse, but it's much easier. You know your application, you know your servers, you know where they need to be accessed. Then, for your applications, create the rules. And that's it. This is on the Terraform file. We explained this Terraform file in the past. One important thing is this information of files and Terraform files that I'm going to use. This is the Terraform file by bucket, and I'm storing all these 4 files in a bucket, and the connector will retrieve the information from the bucket. The bucket has static IP protection, and each time I change something, I add an IP or something on the peers file, automatically when I run Terraform apply, the bucket is updated. The information about the bucket is, if you, or the Terraform, all information is go to documentation and support, close security connector for Zscaler, click here, you will land on this page, on the index page, Amazon, click on documentation, and here you have all the documentation, administration guide, the videos, and the files, and also the Terraform, in this case where I'm using this one. Then ready to go, I added the node. My next step is to update the bucket. Then I will go to my bucket here. Let's do Terraform plan. Okay. It's mentioning that the private access peer file will be updated. Of course, Terraform apply. Yes. Okay, it's done. Now I need the URL of the private access peers file to configure inside the connector. The next step of the presentation are the private apps to the peer.json file. We did it, deploy the peer.json file to all CSEs. Then I need to configure the URL on my CSE, my new CSE, and I need to refresh in the entire network. Let's do the first step. Let's configure the URL on our local CSE. Then I will come here, press enter. Second step is lower JSON file. I will do paste. Do you want to refresh? Yes. Do you want to see? Yes, I want to see in compact. As you can see, there is the Ohio location added here. Do you want to apply values? Yes. Then now the connector, I do this manually here because I want to show something important. The connector is validating everything, is adding all the other nodes, and also is creating automatically the security groups that are needed to allow other nodes to get access to this node. This is done automatically for you. You don't need to do anything manually. Because I updated the peer.json file, I need to inform all other connectors on my network. Then I will go to the system manager here, and if you arrive to this video for first time, the connector is integrated with AWS System Manager. it has the manager inside, and from the manager we can run commands. And one of the commands is to refresh the PRJSON file. Then I will come, this need to be in London. These are my nodes. Not all my nodes are active, some are lost, but what I will do here is to run a command. All my nodes have a tag called PriCPA. Run command, owner by me, and this refresh private access peer URL. And tags PriCPA, add, and rate control. I need to put less than this, because it's a free version of 5. And run. Now, via System Manager is contacting my 21 nodes. I'm trying to contact my 21 nodes because some of them are offline. And each connector now is going to the bucket, is getting the PRJSON file, and is doing the same that we saw here. It's doing the same. It's applying the rules and updating the security groups because we added the node Ohio. It takes a little time but we need to. Okay, the Ohio was fast because was no changes, but the others one need to validate the changes and need to validate the rules and all the stuff. Then it takes some time to update. Most of them are updated now, but let's took time for this. Oh, meanwhile, configure management networks. Okay, this is something important when you apply PriCPA and when you want to, if you want to remote access to this connector, the internal interface, you need to configure the management networks. Then I will do the management networks. Meanwhile, my internal network is refreshing. Then I will go here. 19. Do you want the management network? Yes, I have 3. 19.0.0. 24. Yes, 192.168.6.0. No, that 24. And the last one is 10.63. I don't remember this one. Is this? Yeah, 1. /24, no more, and apply. Okay, this is important because I need to have this ready if I want to connect different things. Because by default, what the connector does is, why we don't need routing. By default, all route private IPs will go via the Ethernet 1 internal interface unless they are defined on PriCPA. But to get access to the connector, because this is zero trust, you're not allowed, you need to create the remote networks to get access. Okay, let's see how the run command is going. We have 16 complete. We have some in progress. We should have some offline, I guess. Okay, all complete, all done. Okay, looks good, brilliant. Then if I come here, and if everything is fine, if I will show peer status with all show peer status. Okay, this is offline. Okay, this is one offline. The others node are alive. Okay, I'm contacting with all of them except one. Well, here is another offline, but this we have plenty of labs here. Okay, that is good. Most nodes are online, and let's do the test now. For the testing purpose, I mentioned that I will use a node in Azure to test connectivity to Ubuntu, for example. I should be able to ping now this device. If the routes are well, yeah, it's okay. But if I want to ping the Bastion host, I should not be able. Okay, this is zero trust in action. And the reason why this is happening, remember we create a rule that will allow all traffic to these destinations, but for this destination is only 22. Then the machine in Azure cannot ping this device, but it is allowed to do telnet. And if I do a telnet, telnet is port TCP 22, the telnet works. Okay. Well, with this little demonstration, we show that that PriCPA works, and that's much it of the presentation. As you can see, it's extremely easy to create PriCPA. It's all about to create the local configuration on board the node, put the subnets behind, and start creating the rules you want. And that's much it. It's extremely simple. Well, this is the end of this presentation. We did the testing now. This is the end of the presentation. If you have any questions, or you can contact me directly or our sales team, or go via our website contact information, or you can go to a support site and to create a ticket. Thank you very much for your time, and have a good day.